Now let's have a look some MC question about mensuration. Okay, so you see some question related to arc's length and area of sector. Okay, but mainly today we discuss about this kind of question. We have some ratios and how to find out the perimeter, or sometimes we talk about the area. Okay, given area and find the perimeter, or sometimes we have the ratio and find the area of some parts. Okay, let's see. Question 8. Question 8. This one related to sample paper, paper 2, question number 18. You can try it by yourself later. Now, this question, let's study all together. In the figure, WXYZ is a parallelogram. P here is a point line on XY, such that PZ is perpendicular to XY. PZ perpendicular to XY. It's given that PZ, this one is 15 cm, okay, and 2xp, this one, equals to 3py, okay. Then here actually you can use a ratio, okay. If the area of parallelogram WXYZ is 300 cm squared, okay, WXYZ, that means the whole parallelogram is 300, then perimeter of a parallelogram is, okay, that means we need to find the length of the parallelogram. And remember, parallelogram will have opposite sides are equal, so this 2 equals and the other 2 equals. Okay, so how to make use of the information? Okay, here 15 cm, area 300, and a ratio of xp and py. Okay, so let's see. Better to highlight all the important information. For example, this one is parallelogram, so you know that they are parallel, they are equal, opposite sides are equal. Then this one 15 are right here, and 2xp equals 3py. Okay, try to think xy separate by p, and what are the ratio of these two lengths, xp and py. Okay, we can start it from here later, and you need to find is the perimeter. Okay, so if you know this length, then all done. Okay, so first, what should you find? Do you know this length, xy? If you need to find the xy, then I think you need to find px and py. Here is the height of the parallelogram, right? So you know this one, that means you can find xy. After you know xy, then you can find this too, right? Because 300 is the area of parallelogram, right? Okay, so if you know this one, actually you know one of the length of a parallelogram. How about zy? Yeah, here you can find it right angular triangle, so better to use this, and you can find out the length of zy. So see, there are several things you need to find. Let's see. Do you know py and xp, their ratios? Okay, but this one you can find it. Then later, find xy by using the area of parallelogram. After you know this one, you know the ratio of these two lengths, then you can use py to find out zy by the right angle triangle zpy. So finally, you can find the perimeter, right? So let's start. 2xp equals 3py. Do you know how to solve it? Yeah, remember, try to think. If you want to find xp to py, that means you need to find xp over py, right? So how to rewrite it? So xp over py equals what? Correct. 3 over 2. Yes. So you know xp to py equals 3 to 2. So here is the colon, here is the equal sign. So 3 to 2. So you may let xp be 3k, py be 2k. That means this one is 3k, this one is 2k. You can think like this, right? So okay. Can you find xy? Yeah. Now we know about the ratio, okay? Not yet know the length, but ratio. So let's see. By using 300, so how can we do? Yeah, let's see. Here, xy times 15, xy times 15 equals 300, right? So, yeah, I need to let. This one is multiple choice, so you can use the easy way to find it. Maybe no need to write too many things. Anyway, I let xp be 2k and py be, xy be 3k should be. And this one is 2k. So as a result, 2k, 3k add up together is times 15 equals 300. So k is 4. Now you can find out all the lengths of py, xp, in the same time also the length of xy, right? So done. How about zy? Yeah, you see here py is 8 cm, xp is 12 cm. So you know this one is 8 now. Okay, I use another color. You know it's 8 now. So is it by using a right angle triangle, remember? So that means this one. Set py, this one. 18, not 18, so 15 and 8. So do you know this one? Yeah, very good. Pythagoras theorem. So this one actually is this. zy squared equals py squared plus zp squared. You can write that as Pythagoras theorem. So at the end, zy equals 17. Wow, you know this one also. So finally, you can find perimeter because this one and this one, you know it. These two opposite sides are the same, and other two opposite sides are the same too. So finally, perimeter of wxyz, okay, is xy plus zy and then times 2. So 8 plus 12 plus 17 altogether times 12. So final answer is 74. So the answer is D. Clear? Very good. Now let's have a look another mensuration MC question about this one, 11. Okay, maybe we study this one. Let's see. Okay, so have a look at this one. Now here in the figure, ABCD, PQDQ, BPDQ, two parallelograms. ABCD, the big one, and the other one, BPDQ, this smaller one. Okay, two of them are parallelogram. Here is point P, line on AD, such that AP, PD, 9 to 5, 9 to 5. Okay, AC cuts at BPDQ at R and S respectively. Okay, ABR, this triangle, you know, okay, this triangle, 252, 252, okay, so area you know only is this triangle. You need to find out the area of DPRS. Or DPRS, that means this part. Okay, how to relate it, this area to this part. Okay, so see, seems like very complicated, and you need to find some relation first. Okay, let's see. I highlight some important information here. APPD, this one and this one. Okay, 9 to 5, 9 to 5. So maybe you write it, oh, here is 9 to 5, that means 9K and then 5K. Maybe you write like this. Okay, okay. And this one is 252 cm squared. So I highlight this one. And we need to find this, the quadrilateral. Okay, quadrilateral, I make it as X. Then how to solve this one? Okay, in this kind of question, first think about is similar triangles. Do you know any pairs of similar triangles here? Okay, how many? Actually, many similar triangles, but I want you to pay attention some pairs of similar triangles. For example, this kind. Okay, this kind. Because they are parallelogram, this one and this one. So you see here as a similar triangles. Maybe I use another color to highlight this one. Right, similar triangles. See? Like this, like this. Okay? So if you know one pair of corresponding lines ratios, then you also know the other pairs of corresponding lines ratios. Okay, so let's see. Okay, I clear this one. Any other? Yeah, here you see these two lines are parallel. Okay, then this triangle and this triangle also similar. Right, any more? Any more? Maybe you say that this one and this one, right? Yes, yes. Any others? So you see, okay, I let you have a look. This one. Just now we say that, okay, APR and CBR. Mainly, if I write this one, I also put it in order APR. So CBR. Okay, so this pairs of parallel similar triangles, and the other APR, and ADS. Yes, this one. Okay, just now we say that's okay. CQS, CBR. Yes. Okay. Okay. So here, actually we use this two. Mainly use this two. Then how to solve this one? How to solve this one? Can you think step by step? Okay. So let's see. Actually, besides similar triangles, actually we need to use another kind of triangles. Okay. This one, ABP. Inside you have two small triangles. And remember, they have the same height. Okay, same height. Okay, so because now here we only have this area ABR, this triangle, and how to link up with X. And you know that this one X actually comes from this big triangle, and then minus this part. If we know the big triangle and the small triangle, then we can find X. Right? Right. However, how to link up this big triangle or this small triangle with this area? Okay? See, here we have same height triangle, ABR and APR, right? So the area of these two triangles, actually the ratio of these two triangles actually is this one to this one. So if you know the ratio of this one to this one, then we can find this area, right? So let's see. Try to find the ratio between BR and RP. Remember the starting, these two similar triangles. That means this one. Okay, see, this one and this one are the corresponding sides. If we know the ratio of the corresponding sides of these two similar triangles, then we can solve it, right? So by using APR and CBR, we can find PR to BR, right? Right. Using ABR, that means 252 to find the area of APR, because they have the same heights here. Okay, so we can use this two ratio, then we can find out the area. If you know this area, actually you know this area because you know the length of the similar triangles APR and ADS. See, if you know ADS, okay, not ADR here. If you know ADS area, okay, then the big one minus the smaller one, you can find X. Okay, so let's go through step by step. Okay. So now let's try. Now here we'll have the area of triangle ABR. Let's try to find APR. Okay, again after that try to find ADS. After that find the area of this quadrilateral. Okay, so let's start. In the question, besides the area, we only have the ratio AP to PD. Okay, AP, PD. And these two lengths helps us to find out the length of BC. You can think it as 9K and 5K all together. That means 14K. So this one, these two similar triangles, then you can solve it. See? Let's start. Now here, AP to PD equals 9 to 5, right? So AP to AD, 9 plus 5. Actually, this one, if we write it, maybe we need to write as 9K to 9K plus 5K. But now it's multiple choice, so I will not write it like this. So this one 9 to 14. As a result, AP to BC is 9 to 14. Remember, they are similar triangles, so you know this length to this length, right? So 9 to 14. Because they are similar, that means PR smaller one to BR bigger one also equals to AP to CB, 9 over 14. So their ratio 9 to 14. Here is 9 and 14. Wow, that's great. We know the length ratio here. PR is 9, BR 14. So we can find out the area now, right? So let's see. So the area of triangle APR, see, APR to ABR actually is equal to the length of PR to BR. Remember why? If they have the same height, then area ratio will be the length ratio. Have a look. The height is h, right? So actually this one, we can say that is half of PR times h. This one is half of BR times h. See? After simplify, the length is PR to BR, right? Okay, now we can find the area of APR. So 9 over 14 times 252, right? So 162. See? Okay. Here is PR 9/14, right? And this one is 252, right? So 252 times this one equals to area of APR. Understand? That's great. That's great. Nearly finished, because now we know here is 162. Here is 162, right? So let's see. Finally, try to find out this. Since now this one and this one also, they are similar, right? So the area of APR to this one, ADS, okay, are the length of AP to AD, AP to AD, and then take square. Remember, similar triangles, if you want to find the ratio of the areas, that means take the length. Okay, maybe now here is the corresponding lengths, and then take square. Okay, remember, A1 over A2 equals L1 over L2 take square. Later on, we can talk about the volume, but this time we only focus in area. So goes on. Here is 162, and then plus X is the bigger one, okay? And the smaller one, 162. So 162 over 162 plus X equals 9/14. So finally, X is 230. So final answer is this one, D. Okay, see? After this question, you can have a look DSE question 2017 question 16. Try by yourself and to see that you can do this question or not. Okay, I think you can. Keep on. Okay, let's see. Maybe you can do this exercise, okay, on this one is page 6, right? Question 12. Try it by yourself. Okay. Now let's have a look. 2012 question 17. Another question. Again related to some ratio, areas, and this time we need to find the area of parallelogram PQRS. PQRS. Okay. Let's study the question first. Okay. In this figure, again parallelogram PQRS. Okay. TU are the point lines on here RS T, and PQ U. SP produce and TU produce ST, not ST, SP, and TU produce to meet at V here. VPPS 225. Better to write as 2K and 5K like this. And RT TS 1 to 7, maybe write as A and 7A like this. Okay, have two different constants related to their lengths. Understand? If you have ratio, you can write like this. You can ratio, you write that like this, but with different constant. Okay. Now if area of this one is 8, this one is 8, okay, cm square. Okay, find the parallelogram area. Okay, area of the parallelogram. Okay, now let's have a look. Just now, the question I will write like this. Okay, 2K, 5K, and this one as 8 cm square, and we need to find the area of whole parallelogram. That means this one. I haven't filled in the color like this. Okay, you know we need to find this area. Okay, and A to 7A. That means 1 to 7. Okay, let's see. If you need to find the area, that means you need to find the base and the height of parallelogram. Maybe I write AB as the parallelogram, okay? Maybe sometimes you write here, but see, any similar triangles. We need to make use of this similar triangles. But you see, this one cannot be this triangles. Then how can we solve it? Actually, we have another similar triangle, this one and this one, okay? VPU and VST, this kind of similar triangles, right? Okay, after we have this straight line AB, APU, and BQU also are the similar triangles. Okay. Okay. So let's start from this similar triangles. This pair of similar triangles. So you know that VPU and VST. Okay. You have the ratio of the length VP and VS. Remember this one 2K, this one 5K? We only have the ratio by using the similar triangles if we want to find the area. Okay? Don't choose 2 to 5 and then think it as 8 and then this part of area is wrong. Okay? So 2K, 7K. You need to think like this. Okay? So finally, VP over VS equals 2 over 2 plus 5. Okay, actually 2K, 2K plus 5K, so there is 227. Okay, remember here we have the length PU and ST. ST, SR. Okay, so find the corresponding lengths and then they have the same ratio. VPVS, okay, PU to PST, VU to VT, okay, all of them have the same ratio 2 to 7. So PU to ST also have this ratio 2 to 7. Okay, okay. So here, if here is 7A or 7, that means what? Oh, this one also 2A, right? Then do you know this ratio? Because 2 to 7, so here will be 2A. How about QU? Do you know? Do you know? See, SR and PQ, they are the same, right? Right. So you know this one. Total is 8A. Here is 2, that means here will be 6A, right? Okay. So if ST now is 7A, PU will be 2A by similar triangles, right? And PQ, SR, they will be 8A. So QU, this part is 6A, okay? After that, PU, QU, you know they have the ratio 2 to 6. Then you know there's two heights of the triangles, okay? This one, APU and BQU. You know here H and H1. So let's see. If we let AB as the height of a parallelogram and use these two similar triangles, okay? These two similar triangles. So you see that PAU similar to QBU, PUA, then QUB, okay? So H and H1 will have the same ratio, 2 to 6. That means 1 to 2. As a result, H1 and H, that means the larger one, H1, equals 3 times of H. And you say that AB is 4H. Okay, now, you see? AB, you know, is 4H. Okay? And how about QR? How about QR? We know that QR actually is PS. That means, okay, here. This one also 5K, right? This one also 5K. But how can we solve it? How can we solve it? Here we have 8 cm squared, right? This one. And you know that this comes from base PV and height of the triangle AU. AU is H, PV is 2K. So by this small triangles, we can find the relation between H, K, and the area 8 cm squared. See? The area of triangle PUV, base PV times height AU. So by using H and K, 1/2 times 2K times H, and you see that, oh, HK times together equals 8. Now we can make use of this value, this relations of H and K. Find the area of parallelogram, because we know the height is here is 4H, right? And the base now is 5K, right? So as a result, see, the area of PKLS actually is the base PS 5K and the height 4H times together. So 20 times KH, that means 8. So at the end, 160 cm squared. So as a result, this one answer is C, 460 cm squared. See? This time we use the similar triangle, okay? PUA, not PUA, I mean this one. VPU and VST, okay? To find out the length, okay, of PU. After that, because you know here is 1 to 7, so in total 8. So this one is 2A, this one will be 6A. And use another similar triangles, see? Okay, to find the ratio between two similar triangles, okay? The length, the corresponding length, and we can solve it about the height of the parallelogram. And here is H, here is 3H, right? 1, 2, 3. So total AB will be 4H. And the base here is 5K. So after that, 8 cm squared help us to find out the relation between H and K. And finally, find the area of the parallelogram will become 20 times KH. So 116 is the result. Understand? Try DSE question 2012, question 17 by yourself. Okay. Now, today we'll have a look at the last question. Okay. Besides, you can also try the 14 and 15 in this exercise. And I would like to discuss the last question, 2020, question 17. This one. Okay, let's see. Now here in the figure, B, C are the points lies on AD, while EF lies on AG, such that AE equals EG. Not E, AEFG. Okay, these two are equal, and they are parallel. Okay, so this one, and this one, right? Given that the ratio between the area ABE, this one, and the area of trapezium BECF 15, okay, then the ratio of the area of trapezium BCFE, that means just now this one, to the area of trapezium CDGF. Okay, that means two smaller trapezium ratio. Okay, how to find it? How to solve it? And you know, do you know here how many similar triangles? Okay, you know the similar triangles, then you can make use of this ratio. Now you know this one is 1 to 15. Okay, that means if here is A, here is 15A. Okay, then remember we need to use this relation, okay, and we need to use area of similar triangle, not the area of this part and this part. You must use the similar triangles area. So this one is 1, 2, that means as a whole 16. not 15. Okay, and also ADG 3. Okay, let's see. Okay, just now you know that this one is equal and this is A, and you know that this one is 15A because this one. Okay, if here is 1 to 15, you can think it as, oh, this one is A, this one is 15A. Okay, the first question again, and the similar triangles, just now I asked you already, so you know these three are the similar triangles, right? Okay, then let's just make use of this two first. That means the smaller one. Two smaller triangles. So BE to CF equals AE, AF equals to AB to AC. Right? Right. That's great. Okay. So how to find out the area of two trapezium? Actually, think about this. Do you know AE, AF, and AG? Okay, the size of three triangles. Okay, not only the parts AE and then EF and then FG. No. Small triangles, second triangles, and the biggest triangles. So length AE, and then second length AF, and the third one AG. Okay. So let's see. If here is A to 15, then take AE to AF and then ratio take square equals to the area ratio. So see, have a look. This is the first step. Okay, step 1. Okay, find this ratio. See, this one is AE and the AF. You know the area is 1 to 15. So as a whole, here is 16. So 1 over 1 plus 15 is 1 over 16 equals AE to AF take square. Again, A1, A2 ratio equals to the ratio of lengths and then take square. Right? So here's 1 over 4 because take the square root of 1 over 16, you know it's 1 over 4. So this one, 1 and 4. And here AE equals to FG. So 1, 2, 3, this part, AE to EF, the middle one, to FG here, 1, 2, 3 to 1. See? Okay, then finally, how about the biggest area? Do you know? Yeah, 1, 2 as a whole. That means how many? 1, 3, 1. That means 5, right? Yeah. So area ratio here. See? The area of ABE to area of ADG, 1, 2, 5. 5 comes from 1 plus 3 plus 1. That means K, 3K, and 1K. So 5K. K to 5K, so 1 over 5. Okay, so take square, 1 over 25. That's great. As a whole, 25, then minus the upper one, 16. So finally, let's see. If you want to find this part, only this part, that means 25 minus 16. See, area of CDGF. Okay, so 25 minus 16. And how about the upper one? Just now is 16 minus 1, so use 15. Right, 15 over 9, after simplify, 5 over 3. 5 over 3. So as a result, this one, C. Answer is 3. See? Okay, hope you understand this question. And now you can try 2020 question 17. Okay. So about the area in mensuration, you can make use of different similar triangles, right? And maybe make use of more than one set, maybe two sets of similar triangles. And sometimes you need to also use two triangles with the same height and find the area ratio by the ratio of their lengths. That means the base. Okay, like this. See? Okay, try more by yourself.